Welcome to the meetup. Our topic today is monitoring and troubleshooting, and we have as our guest Alan Ngai. He's from OpsClarity. He's the co-founder and the CTO, and he's going to present the product for performance monitoring of stream processing applications, and it's pretty sophisticated application that does deep analysis, detects anomalies, and so on. So looking forward to learn about. The second part will be from David Young. He's Apache PMC member and architect, data torrent, and he's going to talk about the data torrent gateway, which is the solution to access and manage applications in an Apex environment on a Hadoop cluster. And it has a REST API that you can use to build tools, so he's going to introduce that component. And a quick announcement also, we have meetups coming up. We have, just before the Hadoop Summit on June 27th, we have a meetup where we will talk about Apache Beam and Apache Apex. Here, same place, that's the Monday before Hadoop Summit, and then we're going to have our presentation on the Thursday, the same week, at the Hadoop Summit, introduction to Apache Apex, as well as a webinar next week, comparison between Apex and Apache Spark Streaming. Okay, with that, I will hand over to Alan, and we will start the presentation.
Hello, hello, hello. Okay. All right, let's try this again. So, what is a data-first application? It's, in our opinion, a data-first application is. Can I cut this out?
Yeah.
Okay.
You can just speak loud.
Yeah, I'll just speak loud. And hopefully this will pick me up. Okay, so a data-first application is any application architecture whose main purpose is to derive value out of data, right? So if you look at any of these business domains here, fraud detection, personalization, IoT, the problems in these domains are primarily solved by data, right? So in our kind of description, a data-first application is an application architecture whose sole purpose is to basically, extract value out of that. So let's see. So the question is going to be, okay, so given that that's a data-first application, what do I mean by application architectures that serve these businesses? So first things first, let's talk about what we call a data-first ecosystem. The primary kind of backbone to any data-first application is the data pipeline. Now, kind of describe that piece by piece. So generally, it looks like you have a data source either from the web or clickstream APIs, events, anywhere from someplace that basically feeds data into your pipeline. That usually gets fed into a message broker like Kafka or SQS or Kinesis or something like that. That gets sent downstream to a stream processor such as Apex or Spark or Storm or Flink or anything like that. And this is basically where your main business logic occurs, to basically take data from various sources, does some sort of processing on the business logic, and then basically sends that downstream, typically to a data sink, generally a NoSQL database like Cassandra or Elasticsearch or something like that. And from that point on, that data gets served as to applications, as test reports, as maybe a search index. But this whole thing is generally what we call a data pipeline, right? So it's a kind of a connected series of services to serve some business function. What's interesting about this pipeline is that it's actually you can actually have multiple applications running on top of this, right? So it's not uncommon for you to, for example, run an analytics reporting tool on top of this, fraud detection, search index, building a search index and whatnot. So you can actually have multiple applications on top of these sets of services, on top of this data pipeline. So of course nowadays data pipelines run on top of elastic infrastructures, whether it's Amazon or Docker. What tends to happen is that the hardware or the virtual hardware on top of which this runs is kind of ephemeral, right? You can resize this, any aspect of your pipeline, Kafka, Spark, whatever. Services can come and go away. And around this, you have your microservices that support your data-first application. So this could be stuff like account management or logins or credentials or whatnot. So this entire ecosystem is what we call a data-first application. The key part of it is the data pipeline. whose purpose is to basically take data from a set of sources, transform them, and derive value, right? Any questions so far? So this is pretty straightforward, hopefully. So OpsClarity, we are a company that runs on multiple data pipelines. So this is a screenshot of our application. I'm going to walk you guys through what this is. So on the upper left-hand side is basically our topology discovery. So what happens is for our customers, they install our agent on their machines. Our agent automatically detects process information, network information, system metrics, and whatnot, and takes that information, sends it to the backend, and we automatically kind of build this topology for you. So all of these are clusters. Sorry, all of these are clusters of services, and basically what happens is, as your topology changes over time, as your services come and go, or they get bigger or get smaller, you have to have a topology that keeps up to date. So behind this functionality here is a topology builder pipeline that basically detects changes in your environment and basically updates this topology in real time. Right? On the right side, I mentioned that we collect data. Yeah. On the right side, it's kind of showcasing our anomaly detection. So we collect metrics from your system. This could be system metrics, this could be service metrics, this could be application metrics or custom metrics. And what we do is that we baseline these metrics. So we understand what the normal value is for those metrics. And so when your metrics become abnormal, we flag that. Say, hey, there's an anomaly, log that as an event, and that's what you're seeing on the right side there. Right? Again, real time. As a monitoring platform, you have to, when something goes wrong, you have to respond right away. You can't just wait half an hour and run a batch job, right? You have to kind of just flag that. Finally, on the bottom is our application rollup, so real-time health. So what we do is we take the raw metrics at the system level for all your hosts, we kind of combine them and roll them up into host health. We take the host health, we combine them and roll them up into service cluster health. We take the service cluster health, roll them up into application health. So the red, yellow, green you see here is basically a aggregate of the raw data that we collect into the system. So as you can see, we're all about real-time pipelines. Our business runs on real-time pipelines. Okay. So let's talk a little bit about the characteristics of data pipelines. So what have we learned? What's common? So typically, data pipelines are heterogeneous, right? So these are a small subset of the technologies out there that you use to build data pipelines. Can they get a raise of hands? How many people who works at companies use at least one or more of these technologies? So more than half, which is what we expect. So yeah, I mean, each of these technologies work differently. They serve different functions, and you kind of glue them together to basically, solve your business components. And it's a lot of stuff to worry about, to set up, to monitor, to write applications for. Secondly, each of these applications or these services are extremely complex, and they kind of have to be, right? So in this day and age, any service you use has to be scalable, it has to be fault tolerant, there can't be a single point of failure. So in order for you to satisfy all those requirements, the internal architectures of each of these services is actually pretty complex. So taking Storm as an example, what does a typical Storm cluster looks like? You have a master host and you have a bunch of workers. Each worker is responsible for a supervisor process. Each supervisor process is responsible for topologies, which consist of executor processes which run one or more spouts, right? So this is the internal Storm architecture. All of this depends on Zookeeper, and every one of these boxes that I've drawn there, they emit metrics, right? So it's almost mind-boggling what you have to understand and learn to be able to monitor just Storm properly. And this is just one component in the pipeline. Kafka is just as complex, Elasticsearch is just as complex, right? So now when you want to actually monitor your business function from end to end, how much knowledge do you actually have to learn and be an expert at in order to do it properly? Does that make sense? Okay. Next, pipelines are by its nature very interdependent. So as an example, here's an example pipeline. Import data, feeding data into Kafka, processed by Apex, writing into Cassandra, served by the web. And let's say that you notice something's wrong with your web report. Like something's wrong with the data, either it's late or the data looks wrong. So the question is, where in this pipeline could the problem have occurred? Anybody want to guess?
So, is it correct that what you are referring to monitoring is monitoring the event log in one way or the other, an event, right?
Monitoring the health of the pipeline.
Can you be precise about that?
So, and I'll talk a little bit more about that in the next few slides, but generally, when you have a pipeline that works this way and something goes wrong, let's say that you open up your web report that's getting generated and you know that it's half an hour late, right? So the question is, why is it half an hour late, right? So what's the debugging process? How would you figure that out in an architecture such as this? From the beginning. Okay, so the question is, where could it have happened? Anywhere, exactly, right? So the problem could have been anywhere. And to your point, the process of debugging this is basically go stage by stage by stage and scan across, right? Basically, you go to one set of services, look at the metrics, look at the logs, SSH into the machines, maybe use Sumo Logic or Splunk, and then you go to another one, and then you go to another one, and then you go to another one. And each of these tend to be different tools, and I'll talk a little bit more about that. But the process to figure out what went wrong is actually very tedious because these are disparate systems, they're heterogeneous, and they're all complex.
So you're not talking about data network related debugging or troubleshooting here. You're only talking about the software level event debugging. Is that correct?
Well, so what OpsClarity does, we're more centered towards metrics, but the metrics can be from anywhere. Metrics can be system metrics, they can be application metrics, they can be data metrics. It doesn't really matter.
So you would look at utilization,
Yeah.
percent of
Yeah.
network interface card.
Yeah, that's one set of data that we would look at. Yes. Okay. So all this basically adds up to pipelines being very, very difficult to monitor. And so what we're going to talk about next is kind of lessons we've learned over time, building our pipelines, tips that you guys can use to basically help make this a little bit more manageable. So tip number one is basically put all your data in one place, right? So out of the box, Kafka, Spark, Elasticsearch, and Ambari Gang, these all have their own UIs, right? So if you want to actually debug or correlate issues, you basically go to like 6 or 7 different UIs and basically figure out what's going on. Each of them, you have to line up the windows and time slices. Each of them present different information, and you kind of have to be an expert to figure out what to look for. So that's just too tedious a process. What you want to do is basically put everything, all your concerns in one place so you can actually very quickly slice and dice and go back and forth, right? OpsClarity, our platform happens to make it easier because we automatically tag the services, we automatically collect the data, and we put it in one place. But even if you don't use us, I mean, there are systems out there like Graphite and whatnot where you can put all the data in one place. It's a lot of work because you have to kind of build a lot of the plumbing yourself. But despite that, if you don't invest the time, you're basically flying blind when these are in production and operation. Right? So put all your data in one place. Second point. Now, and this kind of addresses part of your question. Organize your concerns horizontally. So metrics is at the core of everything, but there is some intersection of concerns for these metrics specific to the data pipeline that you care about, independent of what business you're in, independent of what technology you're using. And these are essentially your data health, quote unquote, concerns, right? So throughput, stuff per unit of time. They could be clicks per second, they could be documents per second, they could be network bytes, in and network bytes out, right? But these are essentially throughput metrics. Right? And it's important, and I'll show you why. It's important to organize your metrics according to these kind of categories. Latency is just how long it takes stuff to go through the pipeline. Error rate is the number of errors that you see as something goes through the pipeline. Buffer rate is how much is being queued up. Data loss and data duplication, self-explanatory. So why is this useful? So let's take this case where it's kind of hard to see here. You'll have to take my word for it. But this is a pipeline where I put all of the throughput metrics in one page, right? And so the question is for those of you who can see, where is the problem occurring? Just by looking at this, is it Kafka? That's a good guess. It's not Kafka.
Elasticsearch.
It's not Elasticsearch either. You're standing too far away, so I'm kind of skeptical that you can see this.
Play.
It's Play. Why is it Play?
Straight line from there.
Yes. Well, it's Play primarily because all of the metrics after Play exhibit the same behavior. You see it kind of being normal, and then it has this drop pattern afterwards. And then everything before it looks normal, right? You can't see it, but it's normal. And it's at Play where something started happening, right? So because I laid all of my throughput metrics on one pane, this pattern is just emergent. It's just obvious. Imagine how hard this would be to see if you had your CPU metrics, your network metrics, your metrics in 5 different tools. It would be almost impossible to see, right? You would have to remember all of this. But because we put all the data in one place, we organize these metrics by these categories, and we say, okay, show me all my throughput metrics. Now you can have a very powerful tool where you can spot patterns very easily. And you can do this for latency, you can do this for error rate, you can do this for any of the other dimensions I talked about. Does that make sense? Okay. So that's horizontally. You can also organize your metrics vertically. So going back to Storm, this was the topology, this was the internal topology, all of the metrics. So the question is, when something goes wrong, where do I start? Let's say I isolate it to Storm. I know it's Storm that's gone bad, but where in Storm has something gone bad, right? So it's also a flood of information. So if you organize your information hierarchically, you can also have kind of a directed search to kind of resolving your issues. So at the top of this hierarchy is the data health. So the number one question is my throughput, latency, and errors okay? If my throughput, latency, and errors are okay, probably it's not as urgent. But if those are affected, even though I get woken up at 2 a.m. in the morning, I want to get on top of it right away. Okay? Since Storm has some dependencies, Kafka and Zookeeper, are those okay? Right? If my dependencies are not okay, there's no point in me kind of going into Storm and going to my application. I should look at what my dependencies are and make sure that they're okay before I go down any further. Next step, is my Storm service okay? Is Storm manages resources? Is the master up and running? Are there enough resources in the cluster? Assuming that the health is okay, is my application running on top of Storm okay? Are my application KPIs behaving normally? If they're not, is that application well distributed in my Storm cluster? So one of the characteristics of Storm, even though it's fault tolerant, quote unquote, is that it has a balancing problem. So run a Storm cluster long enough, and what tends to happen is that your jobs get restarted and they kind of migrate towards a machine. And this is one area, by the way, Apex does a much better job than Storm. So, anyways, so is your application running on the cluster healthy or not, right? Going down, looking at a node, are all my jobs running on this node healthy? So if all of my jobs are bad, something's probably wrong with the service itself. If only one of my jobs is bad, it's probably your application code, most likely, right? And then finally, your CPU, system, metrics, and whatnot. So this is kind of a way for you to think about the data that you're kind of navigating step by step, rather than looking at everything at once. Does that make sense?
So you go top down, not bottom up?
I tend to go top down, yes. Yeah, because it's
like you should first check whether the toaster is plugged in. Start from the top down.
So yes.
And there's a bigger audience being webcasted too, so just repeat the question so that they can hear you. They can only hear the mic.
Okay, so the question is, do you start top down or bottom up? In our experience, we tend to start top down because that's what we care about most. Especially in data pipelines, we care about our data flow, right? A lot of these systems are built to be very resilient, so it's okay for one machine to go down. If my host 1, 2, 3 goes down, but my throughput and latency is not affected, I don't really care, right? I come and fix it the next day. I don't want to respond to every single, kind of alert that happens on all of my hosts. So I do top down because that's the order of concern that I have.
So I said there are more chance there are error on the top, less chance on the top.
It depends. It's hard to say. I would say that when errors happen on top, more people care about it. Right, your managers will care about it. You should care about it. But depends on your application, the characteristics of your application, the reliability of your hardware. What kind of cloud you use. It's in our experience, it's kind of pretty spread across the board. Yeah. Okay. So let me jump into a demo and kind of talk about some of these concepts in our application. Let me see if I can duplicate the screen. You guys can see that. Let's switch over here. So this is our application. Can I minimize this? Sorry, give me a second. What just happened? Okay, sorry, give me a second. I think I closed it by accident. Okay, so just manually expand this. Okay, so what are you seeing here? You're looking at the application. You're looking at the application topology on the left side. You're seeing the event log on the right side, and you're seeing the histogram. And I'll kind of walk through these piece by piece. So right here, right off the bat, what you're seeing is essentially a data pipeline, and I'll kind of highlight that. So on the right side here, you see your kind of your web stack, your Rails server operating on top of Memcache, talking to Cassandra and Elasticsearch. On the left side, you have your ingest server, kind of your gateway, a data pipeline. It feeds into a Python ingest server, feeds into Kafka, that pushes data into Apex, which processes data and dumps it into Elasticsearch, which is being served by the web server. Right? This is, by the way, all auto-discovered, this entire pipeline. So we basically cluster everything together. We figure out this is how everything hangs together. And we automatically collect the data. We automatically set up the alerts on these systems, the metrics to watch and how to watch those metrics. And so what you're seeing here is kind of a reflection of the health of the pipeline in terms of red, yellow, green.
How do you do service discovery?
That's a separate, okay, so I can answer that question later. It's a little bit more involved, but suffice it to say, you look at the signatures on the machine, like process, network, utilization, cluster them together, fingerprint them and say, okay, these set of processes mean you're probably MySQL, or you're probably this or that, and you basically put all that together to build this. So, okay, so let me walk through kind of a debugging session using this. So first and foremost, what I'm going to do is I'm going to highlight everything that's of a different color. So there. Sorry, I'm a Mac user, so I'm trying to figure out these keys. Okay. Nope. Control. Oh, there we go. Okay. So I'm basically selecting all of the resources here that are, all the services here that are red, and what you're seeing here is kind of a health overlay of each of these resources, right? So let me kind of filter everything out but these set of resources to kind of remove the noise, so hide all the selection. Let me also kind of zoom in to this region of time where something happened. So this is, by the way, the histogram of all the events that occurred within this time frame. And on the right side is basically all the events. And as you can see, I can actually click through time. I can start from a place where everything was essentially mostly healthy. And I can basically go forward and see how it, sorry, the network's a little slow, how it evolves over time, right? But anyways, let's go through a debugging session. So I'm at this point in time where I have a bunch of red and oranges, and let me start looking at my web application. So this is my Rails app. And what am I seeing here? I'm seeing my impressions in Asia, my impressions in US, my impressions in Europe drop. And these are anomalies that we detect automatically, right? So something happened that led to a bunch of anomalies and led to this orange status. So let me walk my way upstream to see what happened on the Elasticsearch ELB. If I click on that, look at the request count. This is, by the way, auto-discover from Amazon. So we understand ELBs and we collect data on it automatically. You can see the drop in the request count. If I take Elasticsearch, you look at the number of documents indexed that also dropped, right? Which suggests that something upstream happened, right? Let me go to Apex, which is my my stream processor, and looking at messages read and messages written, they both dropped, as you can see. So that again suggests that something upstream happened, right? Going back up to Kafka, I'm looking at my, the in bytes and the out bytes, again, both dropped. And going back to my Python application, a bunch of stuff happened. Let me click on that. Okay. Here, let me just go ahead and switch on over to the metrics view and just to show you all the metrics that we collect from this Python application automatically. What you see here is the docs received per minute. That looks normal. The queue size here is actually growing from this point in time. You can see that the docs process dropped all of a sudden around this time, and everything else, the errors spiked up here. So in fact, what happened was we deployed a Python new version of this application where we dropped 50% of the documents. So we kind of induced the failure to simulate the effects that you saw. So what you saw on the other page was everything was red, orange, green. And what I was able to do was walk you through kind of the process of figuring out, okay, here's where the problem occurred. Does that make sense? Okay. You can also switch over to the health view. So this is still looking at the Python cluster. And you can see here that my ingest server, misbehave. I can click on that. So this is the actual host. I'm drilling down to the host. And you can see these are the monitors that we set up for this host. So docs processed, docs delayed, click, doc errors, average process time, queue size. And you can see all these monitors that was set up on this host, all got triggered, first from orange and then to red. Make sense? One final thing I mentioned before, organizing your metrics by concerns. So this is a dashboard of just my throughput metrics. And what I've done essentially is basically laid out the various throughput metrics for each service. So on my ELB, I have my request. On my API gateway, I have my bytes in and bytes out. My ingest server, I have docs received, and so on and so forth. And I know the contrast is hard to see here, but if you can actually see this, you'll see, everything looks normal up until basically this guy here where something dropped. And after this, everything starts to behave, exhibit the same behavior. Kind of this early drop. Oops, sorry, I just reorganized it. Sorry, let me just. Okay, so after this drop, everything kind of started dropping around the same time, right? So this is an example of kind of organizing my metrics by concern. Again, this would be really hard to see if I have CPU metrics in here, network metrics in here, and whatnot. So these are just kind of throughput metrics organized in one place. Make sense? Okay. So jumping back to my slide deck, how do I show? Okay. So. Sorry, let me just skip real quick. Okay, so what we talked about today, data-first applications are becoming a thing. I'm sure you guys are aware, otherwise you wouldn't be here. The monitoring data-first applications is hard. Hopefully I kind of give you some inkling that it's actually a very challenging thing. I think at this stage of the company, most companies are figuring out, hey, how can I use these new technologies to kind of solve business problems? And kind of monitoring is an afterthought. But unless you have your data thought out ahead of time and figure out what you want to collect and how you want to collect them, it's actually very hard to understand what your applications is actually doing. So monitoring data first is hard. Get all your metrics in one place, regardless of the platform you use. Organize your data vertically and horizontally. And that's it. Any questions?
So I was curious about whether you build in knowledge to OpsClarity about specific services. Like, this is what signature for running Kafka server looks like. This is what some other service looks like. Versus if somebody started a whole new custom distributed application that you know nothing about, would it perform equally well on both?
So good question. So the question was, okay, it's great that you understand these services that are open source, that are well known, but what if I have custom applications? How do you handle that? So two parts to that answer. First part is, the way applications are being built today tends to be more and more kind of these services and less custom code, compared to say 5 years, 10 years ago. So in our stack, actually, in that topology I showed you, the only place where we had custom code was inside of Apex and inside of the Ruby on Rails. Everywhere else is basically almost 70% of it was just out of the box with some configuration. So that actually takes you a long way. But for custom applications, if you use Python or use Java today, we can recognize that. So in fact, we recognize the JVM signatures and Python signatures. If you are a JVM app, you can enable JMX to kind of dump metrics, and we can pick up metrics from JMX. There are other ways to collect metrics as well. You can write metrics into a log file, and we can just scrape that. There's an API you can write to. So there's a lot of ways for you to get data into our system. Right? But to answer your question, if we see a process signature that we don't recognize, we just say, hey, we don't know what this is, but we know it's a cluster of something. And you can tell us what it is, name it, whatever you want. You can turn on and off plugins, and once you turn on those plugins, then we can monitor it as normal.
Great, thank you.
Yeah.
seems like you're collecting a lot of data in real time, right? So
Yes.
do you use any processing engine one of these, or do you have your own topology for processing this data?
We are actually using a combination of technologies right now. So we started out with Storm. We're playing with Apex right now. We're playing with Spark right now. Storm is kind of a little bit dated. It's like almost five plus years old, and we're kind of seeing kind of the blemishes. Actually, Amol warned me about Storm a few years ago, so I have to give him credit. But yeah, I mean, we're bumping into kind of the performance and reliability issues. So we're using a combination of technologies. On the platform side, we're using Play, we're using Scala. On the backend side, we're using Storm right now primarily. We're using Kafka, Elasticsearch, MongoDB. Yeah.
Is OpsClarity already integrated with Apache Apex?
We're working on it right now. So
Okay.
we have kind of a sandbox version that we're playing with, but it'll be a little bit more time before our marketing guy is somewhere close by. He can answer. But yes, we're working on it right now.
So, is there a specific pattern that you see for the YARN application to identify the spikes and all?
Sorry, is there a
Specific pattern in the YARN application that you see for the changes in the behavior?
for Yarn specifically, we haven't done as much integration with Yarn. I mean, we collect the raw metrics, but we haven't spent as much time on analyzing the failure patterns. What we have done, to kind of give you a little bit of information of our anomaly detection. So even though there are literally hundreds and thousands of metrics, being shipped by all these, services, you can actually categorize a lot of these metrics. So, utilization metrics, memory metrics, garbage collection metrics, throughput metrics, error metrics. You can collapse it down to, less than 20 categories of metrics. And now anomaly detection becomes a little bit easier, right? Because we know that static thresholds don't work well. And you might use statistical methods such as moving average and moving window and whatnot. But depending on the type of metric, it either works well or it doesn't work well. But if you can kind of, how should I say this? So best case scenario is you design a detector specific to a metric, but that's obviously not tractable. But you can certainly design detectors for a category of metrics, and that's essentially what we've done. Let me actually show you an example, if I can. What I mean by that. So if I click on this guy and network, come back please. Okay, so let me click on Kafka and I'll click on configure. And here are all the monitors we configure automatically, by the way. So we do a port check, the standard port check, but we also do out bytes and in bytes. And here we use standard, simple moving average. You can customize these, however you wish, which metric you want to look at. You can add a monitor. Let's say I add a metric, and then you can pick some metric. Let's say CPU, and so that's not coming up for whatever reason. See? Okay, something's wrong with the network. No, actually, sorry, I did the wrong type. So let me do a statistical. Choose type, add metric, statistical, and this is, for example, here's the set of services we support. You click on Java. You can select these categories: heap memory, collection count, whatever. And these categories of detectors can apply to any metric. It doesn't have to be a Java metric.
So can you show the same for Apex?
No, I can't show the same work. That's in progress. Yes.
Yes, question regarding the deployment. How do you integrate this into an existing IT infrastructure? So you have all these different machines, there's different services running. Do you have an agent running?
Yes.
Does it report to a cloud controller, or how does that work?
So the question is, how do you install, how do you get OpsClarity working in a platform? So we basically have an agent running on every machine or every virtual machine. It's just a single command to run it. It basically downloads the agent, installs it, and we do everything else. So once the agent gets installed, it detects the processes. It sends the information back to us. We take that information, cluster it, classify it, and say, okay, you are a MySQL node. Therefore, I send you configuration information. So you don't have to do this yourself. I mean, we know it's MySQL. We know how to configure MySQL. And then the agent gets that information and starts collecting information. In some cases, we might need additional information. Like, for example, we might need, your Java home or
JMX port or whatever, right? And we will use defaults, but you can also customize that as well.
So you have an agent in every node that sends data back to a central location.
That's right.
Right. So, and that central location, there's a server running within the cluster. Is that right?
Yes. So all the agents send the data back into AWS. We're hosted on AWS, and AWS consists of Play, Scala, whatever, our whole backend infrastructure to make sense of that data.
Oh, so it's cloud-based.
It's cloud-based. Yes, absolutely.
Oh, okay. Yeah. So will customers be very concerned about the security?
So the question is whether customers are concerned about SaaS solutions or cloud-based solutions. The answer is we're doing actually pretty well with SaaS-based solutions. I mean, you look at companies like AppDynamics and New Relic and Sumo Logic and Datadog, all SaaS solutions, right? And they've done phenomenally well. So there's enough of a market out there for SaaS solutions, and that's where the trend is going. Any other questions? Are we out of time? Okay, thank you guys. Sachin and I will be hanging out in the back, so feel free to come and chat with us and ask questions.